Good morning, class. Welcome to Chapter 5, supporting hard drives and other storage devices. Here's the objectives for today's lesson. Hard drive technologies and interface standards. A hard disk drive, also known as HDD, is rated by its physical size, capacity, speed, technology used inside the drive, and interface standards. Two types of hardware technologies used inside the drive are magnetic and solid state. Magnetic hard drives, one, two, or more platters or disks, stacked together, spinning in unison inside a sealed metal housing. Firmware controls data reading, writing, and motherboard communications. Read-write heads are controlled by what they call an actuator. Data is organized in concentric circles called tracks. Tracks are divided into segments called sectors. Most current drives use 4096 byte sectors. Form factors for internal magnetic hard drive are 3.5 for desktops and 2.5 for laptops. That's the size. Here's the inside of a hard drive. Here's the actuator. This is the actuator. This is called the actuator arm. Here's the read-write head, platters or disk, and the spindle on top. This right here is the circuit board. A magnetic hard drive for desktop is larger, of course, than those on the laptop. Solid state drives are the new drives that we use now, also called a solid state device. No moving parts. As you can see here, all these are moving parts here, especially here, the actuator arm. Built using non-volatile memory, similar to that used in USB flash drives. Memory in an SSD is called NAND flash memory. Lifespan is based on the number of writes operations to the drive, expressed as TBW, terabytes written, or DWPD, drive writes per day. Solid state drives are more expensive than magnetic hard drives, but they are faster, more reliable, last longer, and use less power than magnetic drives. Less power means less heat. Three popular form factors used by SSD: 2.5, M2, and PCI Express. And here's what it looks like. Hybrid hard drives, HHDD, is sometimes called solid state hybrid. Contains both magnetic and SSD technologies. The magnetic drive in the housing permanently holds data. The flash component serves as a buffer to improve drive performance. The operating system must support a hybrid drive in order for it to function. Logical block addressing and capacities, low-level formatting, sectors, markings are written to the hard drive at the factory, not the same as high-level formatting performed by the operating system installation. Firmware, BIOS, UEFI, and the OS use logical block addressing to address all hard drive sectors. Size of each block plus total number of blocks determine each drive capacity. Smart, self-monitoring analyst and reporting technology is used to predict when drives is likely to fail. System BIOS UEFI uses smart to monitor drive performance, temperature, and other factors. For magnetic drives, it monitors disk spin-up time, distance between head and disk, other mechanical activities of the drive. If Smart suspects a drive is about to fail, it displays a warning message. It can be enabled and disabled in BIOS UEFI. Four interface standards used by hard drives include IDE, which is outdated, SCSI, which is outdated, SATA, and NVMe, which is the new one. IDE, also known as Parallel Standards, PATA, allows for one or two IDE connectors on the motherboard using a 40-pin data cable. Two types of IDE cables are the older cable with a 40-pin connector with 40 wires and a newer cable with the same 40-pin connectors and 80 thinner wires. The maximum length of an IDE cable is 18 inches. And here's the old IDE. You guys must have seen this. They used to always also call this ribbon cable. Right? Here's the 40 pins in here, 40 pins on one side, 40 pins on another. Now, one difference is you you can buy a cable that connected two drives, right? It had another one of these in the middle. So you could actually connect. It's not like SATA. SATA you can't connect. You can only connect one drive. Here, these old PATA cables, you can do two. SCSI. In the past, hard drives designed for high-end workstations use SCSI, Small Computer System Interface standards. SCSI can support 5 up to 7 or 15 SCSI compliant devices in a system. A SCSI expansion card called the SCSI host adapter used a PCIe slot and provided one external connector for an external SCSI and one internal connector for internal SCSI device. Here's what it looked like. Yeah, SCSI is old. SATA. Most hard drives today use a serial ATA or SATA interface standard. SATA uses a serial data path. A SATA data cable can accommodate only one SATA drive. There's three SATA standard: SATA 3, SATA 2, and SATA 1. SATA support standards are used by all hard drive types. Supports hot swapping, which means if you need to replace it, you don't need to shut off the computer. That's what hot swapping. Can connect or disconnect the drive while the system is running. Connects to one internal SATA connector on the motherboard via a 7-pin data cable. Uses a 15-pin SATA power connector, where the old one, the IDE, uses a Molex connector. A motherboard may have 2 or more SATA connectors. Use connectors in order recommended in the motherboard user guide. Also, if you have a SATA 3 cable and you plug it into a SATA 2 slot, it's going to run at the SATA 2 speed. And here it is. That's the SATA right there on the motherboard. And there's the power connector, and there's the data connector. You see this different. On the old IDE, this was a Molex. The SATA 3.2 revision allows for PCIe and SATA to work together in a technology called SATA Express. It uses a new conductor. SATA Express is not as fast as NVMe. A motherboard or expansion card can provide external SATA or eSATA ports for external drives. eSATA drives uses a special external shielded serial ATA cable up to 2 meters long. Purchasing considerations: SATA standards for the drive and motherboard need to match. If they don't match, the system will run, as always with computers, at the slower speed. NVMe, non-volatile memory express interface standard, is used only by SSD. Comparison: the most common SATA standard, SATA 3, transfers data at 6 gigabits per second. NVMe uses the common PCIe standard, PCIe 3.0, which transfers data at 32 gigs per second. PCIe NVMe interface might be used in 3 ways: PCIe expansion slots, U.2 slots, or M.2 slots. And here's what it's look like. You can install up to 4 M.2 SSD in a bootable RAID array on an adapter card. And this one is by Asus. Topics covered in this part of the chapter: selecting a hard drive, installing installation details for a SATA drive, how to install a hard drive in a bay too wide for the drive, special consideration to install a hard drive in a laptop, and how to set up a RAID system. The motherboard and hard drive must support the same interface standards. Find out by reading the motherboard manual. Options for compatibility. SATA ports on a motherboard are usually color-coded to indicate which SATA standard the port supports. M.2 slots might support PCIe 3, 2, SATA 2, SATA 3, or USB 3.0. When an M.2 port with a card installed is using a SATA bus, one of the SATA ports might be disabled. NVMe expansion cards most likely use PCIe X4 version 3.0 slot. Consideration when selecting a hard drive: technology, form factor, that's the size, capacity, data transfer rate, as determined by the drive interface. For magnetic drives, the spindle speed, which affects performance. For hybrid drives, cache or buffer size, which affects performance. Here's the different manufacturers listed. These are the most popular ones. A SATA drive might have jumpers, most likely set by the factory, as they should. Some SATA drives have two power connectors. Choose only one to use. Never install two power cords at the same time. Here's one with jumpers. Steps to install SATA drive. Step 1. Best as you can, protect the user's data. Back up any important data to other media and verify you can access the data on the media. Step 2. Know your starting point. How's your system configured? Is everything working properly? Write down what you know about the system. Step 3. Read the documentation and prepare your work area. Read all the installation instructions first. Visualize all steps in the installation. Protect against ESD and avoid working on a carpet, because that's what you get, ESD, one of the ways. Step 3, read the documentation and prepare your work area. Again, add precautions. Handle the drives carefully. Do not touch any exposed circuitry. Prevent other people from touching it. Drain static electricity from the package and from your body by touching metal for at least 2 seconds. If you must set it down, place the component side up. Do not place the drive on the computer case or on a metal table. Install the drive, shut down the computer and unplug it. Decide which bay will hold the drive. Slide the drive in the bay and secure it. Usually has 2 screws. Use correct motherboard SATA connector and connect a 15-pin SATA or 4-pin Molex power connector for the power supply to the drive. Check all connections and power up the system. Verify that the drive is recognized correctly via BIOS UEFI. And here's a picture. That's the data connection. That's the power connector right here. And here's looking it up at the UEFI. You are ready to prepare the hard drive for first use. Boot from the Windows Setup DVD. Follow the directions on the screen to install Windows on the new drive. If you're installing a second hard drive with Windows installed on the first drive, use Windows Disk Management utility to partition and format the drive. Installing a drive in a removable bay. Unplug the cage fan from its power source. Turn handle on each locking device counterclockwise to remove it. Slide the bay to the front and out of the case. Insert hard drive in the bay. Use 2 screws on each side to anchor the drive into the bay. Slide the bay back to the case. Reinstall the locking pins and plug the cage fan power cord. Installing a small drive in a wide bay. Use a universal bay kit to securely fit a small drive into a bay. The adapter spans the distance between the sides of the drive and the bay. This is an example of that. That's it right there. You can use this kit. If it's too small, you can use this kit, screw it on there, and then screw this on the case, and it'll fit. Installing an M.2 SSD card. Read the motherboard manual to find out the types of M.2 cards the board supports. Do the following to install the card. Measure the length of the card and decide which screw hole for the M.2 slot the card requires. Install standoffs in the hole. Slide the card straight into the slot, but not from an upward angle. Install 1 screw in the standoff to secure the card to the motherboard. Start the system. Go to BIOS. and make sure the M.2 card is recognized by the system. Installing a hard drive in a laptop. General guidelines: see manufacturer's documentation for drive sizes, form factors, and connector types. Be aware of voiding the manufacturer's warranty if you open it. If the old drive has crashed, you need the recovery media to reinstall Windows and the drivers. If you're upgrading from a low capacity driver to a higher capacity driver, you need to consider how you would transfer the data from the old drive to the new one. Consideration when shopping for a laptop drive. Laptop drive is between 2.5 or 1.8 inches wide. Some high-end laptop uses M.2 SSD. For 2.5 drive, expect to use a SATA interface. Older laptops require disassembly. Newer laptops should be easy to replace. Power down the system, remove any peripherals, and remove the battery pack. Remove a screw that holds the drive in place. Open the lid of the laptop slightly. Turn the laptop on its side and push the drive out of its bay. Remove the plastic cover from the drive and move the corner to the new drive. Insert the new drive in the bay. Replace the screw. Power up the system. BIOS UEFI should recognize the new drive and search for an OS. If the drive is new, boot from Windows Setup or Recovery DVD and install the OS. Setting up hardware RAID. RAID is a redundant array of inexpensive disk or a redundant array of independent disk, a technology that configures 2 or more hard drives to work together as an array of drives. So basically, a RAID is 2 or more drives, physical drives, that logically work as one, like if it's one drive. Why use RAID? To improve performance by writing data to 2 or more hard drives so that a single drive is not excessively used. To improve fault tolerance by writing 2 copies of it, each to a different hard drive. Types of RAID: spinning, sometimes called JBOD, just a bunch of disks. Uses 2 hard drives to hold a single Windows volume. When one drive is full, data is written to the second drive. RAID 0 uses 2 or more physical disks, writes to a physical disk evenly across all disks so that no one disk receives all activity. Windows calls RAID 0 a striped volume. RAID 0 is you have 2 drives and they each share the work. And what does this do? This makes the hard drive or the RAID work faster. Gamers like to do this. They like to do this type of setup. The only thing is, if one of the drive dies, you lose all your data. RAID 1 mirroring or mirrored volume duplicates data on one drive to another and is used for fault tolerance. RAID 1, you have 2 drives, right? And one is you use it to run it, and the other one is copying everything that's on the first drive. And that's used for fault tolerance. If one drive dies, the other one takes up the slot. But there's a disadvantage because you're paying for 2 drives, but you're really only using one. You're only going to use one. So you're paying double the hard drive space, but using half of them. RAID 5 uses 3 or more drives, stripes data across the drives, and use parity checking, and data is not duplicated. RAID 5 is usually 3 or more disks. The good thing about that is if one drive dies, the other drives still have all the data in it, so you could continue working, but you will take a performance hit because if one of the drives dies, it's considered to be what they call in degraded mode, and it won't. You'll notice the accessing files on that RAID will be really slow. RAID 10 or RAID 1 plus 0, pronounced RAID 10, combination of RAID and a RAID 1 and a RAID 0. It takes at least 4 disks and data is mirrored across pair of disks. So here is JBOD spanning, right? One drive is done, the other one continues. RAID 0, they both sharing the load. RAID 1, they're duplicates. And RAID 5, right? They all have parity written, so one drive is allowed to die, and the data will still be there. RAID run, 2 pairs of mirror disk. RAID 10, mirrored and striped. Hardware RAID can be set up using a RAID-enabled motherboard that is managed in the BIOS UEFI and a RAID controller card. For best performance, all hard drives in an array should be identical in brand, size, speed, and other features. Just buy the same ones. If Windows is to be installed on a RAID hard drive, RAID must be implemented before Windows is installed. General directions to install RAID 5 array using 3 matching SATA drives. Install drives in the computer case and connect each drive to the motherboard. Boot system and enter BIOS UEFI. Verify drives are recognized. Select option to configure RAID to configure SATA and select RAID. Reboot the system. Press Ctrl I to enter the RAID configuration utility. Select option 1 to create a new RAID. Under the RAID level, select RAID 5 parity and strip size value. Enter the size of the volume. Select create volume to complete the RAID configuration. And there it is. Here it is. Now, once you do this, you can't go back. Network attached storage. Hard drives are sometimes stored in external enclosures. Makes it easy to expand storage capacities of a single computer, or make available hard drive storage to entire network. For a NAS, network attached storage, this enclosure connects to a network via Ethernet port. Hard drives inside the enclosure might use a SATA connection. I actually have one of these. It's actually pretty cool. What to know about supporting external enclosures? An enclosure might contain firmware that support a RAID. To replace a hard drive in the enclosure, see the documentation for the enclosure. If a computer case is overheating, remove hard drive from the case and install them in an external enclosure. It is better to leave the hard drive that contains Windows installation in the case. You can purchase a SATA controller card that provides external eSATA connectors to be used when the motherboard eSATA port is not functioning, or the motherboard does not support a fast SATA standard that your hard drive uses. This section covers file systems that other types of storage devices use. The following types of storage devices: optical disk, which are DVDs, CDs, and all that, USB flash drives, and memory cards. File systems used to manage data stored on a device. Overall structure in an OS uses to name, store, and organize files on a drive. In Windows, each storage device or group of device RAID is assigned a drive letter and is called a volume. Formatting, installing a new file system on a device. Type of file systems: NTFS, which is the one that Windows uses now, exFAT, FAT32, and FAT. CDFS, compact disk file system, or UDF, universal disk format, are for DVDs, CDs, and Blu-rays. A new version of UDF is used by DVDs and BDs, which are Blu-rays. Here's your 16 gigabit USB flash drive is using FAT32 file system. CDs, compact disc, DVDs, and Blu-rays are use similar laser technology. Tiny lands and pits on the surface represents bits read by a laser beam. Optical disc, this can be written to one side of a CD or one or both sides of a DVD or Blu-ray. DVD or Blu-ray disc can handle data in 2 layers on each side. Here's the capacities of CDs, DVDs, and Blu-rays. Right? Some of them go up to 128 gigs. Wow. I thought 100 gig was the biggest one. Optical drives and burners. Blu-ray drives are backward compatible with DVD and CD. What does that mean? That means you can put a CD or a DVD in a Blu-ray drive and it'll work. And DVDs drives are backward compatible with CDs. That means you can put a CD in a DVD drive and it works. Depending on the drive features, an optical drive might be able to read and write to BDs, DVDs, and CDs. A drive that can write disc or copy to a DVD or a Blu-ray is commonly called a burner. Today's internal optical drive interface with the motherboard via SATA connection. An external drive might use an eSATA or USB port. And here's a picture of a DVD writer or burner. Installing an optical drive. Internal optical drives on today's computer uses a SATA interface. An optical drive is usually installed in the drive bay at the top of a desktop case. After installed in the bay, connect the data and power cables. Windows 10, 8, and 7 support optical drives using its own embedded drives without add-on drivers. For some systems, you would need first, if you want to replace an optical drive on a laptop, you need first to remove the keyboard to expose the optical drive. Replacing the optical drive, shut down the system, unplug the AC adapter, and remove the battery pack. Remove the keyboard. Not all laptops require this step. Some of them are right on the side. Remove the screws holding the DVD drive to the laptop. Slide out the drive out of the bay and a new drive into the bay. Ensure connection with the drive connector at the back of the bay. Replace the screw. And here it is. But to tell you the truth, guys, nowadays we don't really have. They don't really. I don't know. I bought a laptop last year. No, yeah, November, and it didn't come with a DVD. And I also bought a computer about the same time. It didn't come with a DVD. Think about it. When was the last time anybody has bought a DVD in the store or a Blu-ray in the store? Since we now stream everything, right? Watch everything on the internet, Netflix, Hulu, all that stuff. There's really no need for DVDs. So, laptops have stopped having them in laptops because even though you're not using it, you're still using power. So they removed it, and with the advent of the USB, if you really need one, you could just buy one and then add it on. So I ended up having to buy. I bought one, and it works on both my computer and the laptop because it's USB based. But most don't come with DVDs nowadays. Solid state storage includes SSDs, USB flash drives, and memory cards. USB flash drives go by many names: flash, pen drive, jump drive, thumb drive, key drive. Flash drives might work at USB 2.0 or 3.0 speed and use FAT or exFAT file systems. Windows 10, 8, and 7 has embedded drivers to support flash drives. Memory cards might be used in, these are the ones that are used in cameras, tablets, smartphones, MP3 players, digital camcorders. Most laptops have memory card slots provided by a built-in smart card readers, but not so much anymore. Secure digital or SD cards are the most popular memory cards. 3 standards for capacity used by SD cards: 1 regular SD, 2 SD high capacities or SDHC, or SD extended capacity or SDXC. SD card come in 3 physical size: full size, mini, and micro. SDHC and SDXC slots are backward compatible with SD slots. You cannot use an SDHC card in an SD slot, or an SDXC card in an SDHC or SD slots. SD and SDHC cards use FAT file system, and SDXC cards use exFAT file systems. And here's a picture of your different cards. I'm sure you guys have seen these cards before, especially if you have an Android. Problems caused by troubleshooting hard drives. Problems caused by hard drives during the boot can be caused by hard drive subsystems, file systems of the drive, file systems required by Windows when it begins to load. When trying to solve a problem with the boot, decide if the problem is caused by hardware or software. Slow performance. What are the most common complaints? Computers running slow. The overall performance of a system depends on individual performance of the processor, motherboard, memory, and hard drive. To optimize the drive, you can use Windows tools or tools provided by the hard drive manufacturers. Use the Windows defrag and optimization tool to verify that Windows is defragmenting a magnetic drive and trimming an SSD drive. Here's an example. Windows reports volume C is trimmed and volume D is not fragmented. Hardware problems usually show up at the post. That's when you first turn it on. If BIOS UEFI cannot access the drive, the cause might be due to the drive, data cable, electrical system, motherboard, or loose connection. Things to do and check before opening the case. Check to see if the BIOS UEFI displays a numeric code or other message during post. Check BIOS UEFI setup for errors in the hard drive configuration. Try booting from another bootable media. For RAID array, use firmware utilities to check the status of each disk in the array and check for errors. If the problem is still not solved, open case and check these things. Remove and reattach all drive cables. Remember, you started at layer 1, right? Physical layer. If using a RAID or SATA card, remove it and reseat it or place it in a different slot. Inspect for drive for damage. Determine if the hard drive is spinning by listening to it. And make sure it's making a good noise, not a cranking noise. Check the cable for frayed edges. Check the installation manual. Smart errors means data should be backed up and the drive replaced as soon as possible. Use Windows tools for checking a hard drive. Windows 10 8.7 startup repair or the check disk command. If the problem is still not solved, open the case and check these things. Steps to take to repair an MBR hard drive. Repair the BCD using the bootrec /rebuild PCD command in the command line. Repair the boot sector using the bootrec /fix boot, also the command line. And replace the MBR using the bootrec /fix MBR, also the command line. Check the manufacturer's website for diagnostic software. Move the device to a working computer and install it as a second drive. Try these things to clean the drive and get a fresh start. Format a hard drive first. Use this part to start over with a fresh file system. And again, if you format the hard drive, you're erasing everything that you have. So make sure you have a good backup. If the problem is still not solved, open the case and check these things. Exchange the 3-field replaceable unit, the data cable, the storage card, and the hard drive. Try connecting the drive data cable to a different SATA connector. Reconnect or swap the drive data cable. Reseat or exchange the drive controller card. Exchange the hard drive for a known good drive. If the drive whines loudly, replace it. A bad power supply or a bad motherboard might also cause a disk boot failure, but you'll see other things that are wrong. So, and here's the chapter summary, and that's it.